we're looking at some key concepts associated with statistical hypothesis testing. In our last video, we saw that a criminal trial is an example of a hypothesis test. Our null is that the defendant is innocent, and we believe that until the defendant is proven guilty beyond reasonable doubt, our alternative hypothesis. Now understand that juries are not infallible. They're made of human beings. People occasionally make mistakes. And in a criminal trial, there are two possible mistakes that could be made. One is that we might convict an innocent person. Conversely, we could also set free a guilty person. In general, in any hypothesis test, these two types of error are going to obtain. We might reject the null hypothesis when it's really true. Alternately, we might not reject the null hypothesis when it's really false. This first type of error is called a type 1 error. Any guess as to what the other type of error is called? Yeah, that's right. I swear, statisticians are really boring when it comes to thinking up technical terminology. Type 1 error, to reject the null when it's true. Type 2 error, we don't reject the null when it's false. And we need to remember what these two things are. Here's some help in that direction. Reject the null if it's true. Don't reject the null if it's false. R, T, D, F. R, T, D, F. This, of course, stands for Royal Tasmanian Defence Force. Don't laugh. It's stupid, but it works. If you don't like this one, we've got the Stetson Special. Real Texans detest fedoras. They wear Stetson hats. I'm offering a bounty for the best stupid mnemonic device to help us remember this. Reject the null if it's true. Don't reject if it's false. RT, type 1 error. DF, type 2 error. Okay, that's all well and good for you retired intellectual types. But as a tax-paying, law-abiding citizen, I think it is absolutely crucial that our liberal courts and liberal lawyers and liberal judges never, ever, ever set free a guilty person. So what do we need to do to make sure we never, ever, ever set free a guilty person? That we never, ever, ever make a top 2 error. So what do we need to do? That's right. Convict them all! Convict them all! Of course, there's a downside to that, isn't there? If we convict them all, not only are we convicting all the guilty people, we're convicting all the innocent ones as well. We've got our type 2 error rate down to 0, but our type 1 error rate is now 100%. Conversely, you've heard my redneck. Let's see if I can do a bleeding heart liberal. Gasp. This really ought to be done with a California accent. Gasp, sigh. We must never convict an innocent innocent person. Sniff. Sob. What do we need to do to make sure we never, ever, ever make a type 1 error and convict a innocent person? Why, let's just set them all free. And once again, there's a downside to that. We never convict an innocent person, but we never convict a guilty one either. Our type 1 error rate is down to 0, but the type 2 error rate is 100%. And this pattern will happen in general. We can make fewer type 1 errors, but it's going to mean more type 2 errors. And vice versa, reducing the type 2s is going to mean more type 1 errors. That magic 5% number we've been using, tradition, that 5% number is the type 1 error rate. Think about why. We've used the example of tossing a coin. It's entirely possible to toss a perfectly fair coin and get a really odd, unusual result. 90 heads. We reject the coin. It's a fair coin, but we've rejected it. We've made a type 1 error. And traditionally, we do that 5% of the time. We traditionally set a 5% error rate. That error rate is sometimes called the significance level of the test. Remember what statistically significant means? Significant means we reject the null hypothesis. You'll also sometimes use the phrase alpha level. The Greek letter alpha is often used as an abbreviation for that type 1 error rate. And while that type 1 error rate is traditionally 5%, it doesn't have to be. The next video, we'll look at a couple of examples of type 1 error rates where we don't use that traditional 5%.